All right, here's our second example right here. So in this one, this is a very, very simple problem. So I want to go ahead and you've got a word problem, but all we have to do is just look at it and see how we can get our information from it to plug into the equation that we need. So here's the problem. A pendulum that is released to swing freely travels 18 inches on the first swing. On each successive swing, the pendulum travels 80% of the distance of the previous swing. What is the total distance the pendulum swings? Now, remember, a pendulum is just a little metal piece that's attached to a straight line, a swing, or a string or some sort of metal object. When it's pulled to one side and let go, it just travels a distance and swings back and forth. Evidentially, the distance, it slows down each time and it's not as great. So eventually, it stops because of friction or air. But without that, it would just keep going infinitely. So we're going to pretend that that's the case. And we're going to go ahead and look at this. And let's see what information we can pull from this. Now, we're given the initial value. It's 18 because on its first swing, it was pulled 18 inches. Now, we know the rate at which it slows each time. So this right here is going to be our ratio. It slows by 80%. 80% as a decimal is 0.8. And we know that each time it slows by 0.8. So that's just 0.8 squared, 0.8 cubed. The next one would be our original distance times 0.8 to the fourth, and so forth. So let's go ahead and, in this example, we'll pull the information. Now, here's our infinite geometric series. We've got 18 plus 18 times 0.8. Remember, we want to know the total distance. Then 18 times 0.8 squared, 18 times 0.8 cubed. Now, right here, you should be able to determine that this is a geometric series right here. We've got A1, 18, times our ratio, which is 0.8. So let's go ahead, and we've got A1 and R. So we write in our general equation, and we know because R is less than 1, we can find the sum for this. So let's go ahead and plug in A1 and R. So we get 18 over 1 minus 0.8. We're going to get 18 over 0.2, which gives us 90. 18 over 0.2 gives us 90. So the total distance that this has swung is 90 inches. Remember, 18 inches. So that's the total, that's the units that we're measuring. So 90 inches, if we convert that to feet, that would be 7.5. So we just asked for it. I mean, inches is fine because that's what the unit that it was given in. But remember, you always have to see what units we ask it to be in. In this case, inches is fine. 75 point feet is fine too. Now, what I want you guys to do, if we look at this next problem, I want you to do two things right here. The first thing I want you to do is I want you to look at this problem. So let's say we did that exact same problem, and the only thing we changed is the distance that the pendulum travels on its first swing. So suppose the pendulum travels 10 inches. Remember, in example 3, it traveled 18 inches at first. But in this example that we're looking at here, it's going 10 inches. So remember, you can go back. I'm putting the notes up right here. And you can look at this. But what I want you guys to do is I want you to answer this problem right here. Suppose it traveled 10 inches on its first swing. So instead of 18, it's going 12. Go ahead and answer that in the first text box that pops up. All right, the second thing that I want you to answer, because I think that it's important for you guys to be able to do this in word problems. Let's say we have the same type of problem. A pendulum that is released to swing freely travels 100 centimeters on its first swing. On each successive swing, the pendulum travels 96% of the distance on the previous swing. What is the total distance that the pendulum swings? Now look, this is in centimeters, so you can give the total distance in centimeters. Again, if you have any confusion on this, go back and look at example 3. Okay, it's about a minute ago. Go look at that, and you should be fine. Again, don't write in, I don't know or I don't understand. The example is literally the exact same.